Hi, welcome to our math. Today I'm doing a series of videos on complex numbers. In this video, I'm going to just introduce what a complex number is and give a few rules to kind of summarize what we're talking about. The first thing I want to say is a complex number is a type of number. It doesn't mean it's complicated. So given a real number, with a and b being just real numbers, a complex number is written in the form of a plus bi. A is the real part, and b is the imaginary part. I is just defined as the square root of -1. It's imaginary because you can't have a square root of a negative number. And mathematicians, like any kid who doesn't like their broccoli and feeds it to the dog, hid the part of the number that can't be dealt with under a letter I and said, hey, it's imaginary. We don't want to deal with it. I squared then becomes -1. I cubed becomes negative the square root of, well, it becomes negative square root of -1 cubed, which means it becomes negative I. And I to the fourth actually becomes a positive 1. So these are the only 4 answers you get. So I to any exponent is either I, -1, negative I, or 1. And honestly, if I had like I to the, 300, I'd take 300, divide it by 4, find out that that equals something with a remainder of 0. The remainder is the exponent I look for. And because the remainder is 0, which is equivalent to this, it's going to be a positive 1. So you just look at the remainder and it's either I, -1, negative I, or 1. And that's going to take care of all of your I needs. Okay, what else? If I have the square root of -16, we just separate this. We say it's -1 times square root of 16, which is I times 4, which we actually write as 4i. We do the real part before the imaginary part. It just reads better. Any number can be considered, any number can be considered complex. So if I have 3 plus 0i, it's actually equal to 3 with real and complex, though the complex has been zeroed out. If I have 2 plus 4i, this is just complex. It's complex because it's made up of both the real and the complex part. It has both parts in there. If I have 0 plus 7i, this is considered purely imaginary because the real part has been zeroed out. So every complex number, a plus bi, where b isn't 0, has a complex conjugate. This has been broken up. Weird, a minus bi. These pairs become really important, especially when you start looking for zeros of a polynomial, because they get paired up. If a plus bi is 0 of a polynomial, so is a minus bi. So once you start getting into polynomials, which is why we learn about complex numbers, honestly, a plus bi and a minus bi are always partners in crime. So it's important to remember that. Okay, so there are some rules. How far up do I want to go? Let's go to there. There are some rules for complex numbers. And this has to do with basically the basic algebra of complex rules or complex numbers. So the first is to add or subtract complex numbers /subtract. Real / complex parts separately. So if I have 5 plus 3i plus 8 plus 2i, it's going to be 13 plus 5i. I add the 5 plus the 8, I add the 3i plus the 2i, and that's it. That's all that part 1 is saying. To multiply, use distributive property. So if I have 3i times 2 plus I, it's going to become 6i plus 3i squared. That, of course, is -1. So 6i plus 3 times -1, or 6i minus 3. To divide, if the complex part is in the denominator, if it's in the numerator, we don't care. Multiply numerator and denominator by complex conjugate. So if I have 6 over 3i, the complex conjugate of this is just going to be 3i, or just I. I just need to get rid of the I. So I should do 5i, so it doesn't naturally reduce. So if I just multiply by I over I, I'll get rid of that I to give me 6i over 5i squared, which is 6i over, that's a -1, -5. And now the I is no longer in there. That's not nearly as interesting as if I have 6 over 5 plus I. The conjugate, complex conjugate here would be 5 minus I. Now, as to how this reduces, I have videos on this, trust me. But this is really just a difference of 2 squares. It's going to end up being 25 minus I squared. So I end up with 6 over 5 minus I, this is -1, over 26. Now, yes, I did all of that very fast. I have videos on adding, subtracting, multiplying, and dividing. It is all there. This was just a quick review of how the rules look in action, so they just weren't words on a sheet of paper. Go on to the actual examples of all of these different algebraic applications of complex numbers. You will see how they go much more slowly. I promise you I don't do everything this fast. I just wanted you to quickly see what I meant by the words, because sometimes words can be confusing without something visual. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video.